Hi there, mathematicians. Let's get started with the equations of parallel and perpendicular lines, section 3.6, the last section of unit 3. Alright, so our essential question, how can you write an equation of a line that is parallel or perpendicular to a given line and passes through a given point? So our objectives are that mathematicians will be able to write equations of parallel and perpendicular lines, use slope to find the distance from a point to a line. Alright, so just do a quick refresh, just so you know all your coordinate geometry information, in other words, the algebra components of geometry, can be found in your interactive notebook, page 6. So find this section titled Coordinate Geometry in your notebook right now, so you can reference the different types of equations and do a refresh for Algebra 1 and how we will incorporate these lines, these various types of lines, into this current unit. Alright, so when we're writing equations of lines, there's multiple ways that we can do this. It just depends on what information you're given. So option number 1, if you're given the slope and a y-intercept, then you can use what's called the slope-intercept form, which is your y equals mx plus b. And on your formula chart, you'll see this information, so it'll say slope-intercept form of a linear equation, and there you go, y equals mx plus b. So let's take a look at this extra example. We're going to write an equation of a line with slope 3/2 through the point 0, 3. Notice this coordinate. If we were to plot this on a graph, where would it be located on a grid? Well, hopefully you go up 3 along the y-axis, meaning it's the y-intercept. So the b value in the form of a coordinate is a 0x value, and then the place where it intercepts the y-axis. In this case, we want it to intercept at 3. So that makes the b value 3. And then 3/2 will go in place of m. So your equation should look like this. Y equals 3/2 x plus 3. Alright, option 2 for writing an equation of a line can be if you are given the slope and a point. Then we can use the point slope form, which is y minus y1 equals m times x1. So on your formula chart, you can find point slope form of a linear equation, and there it is, the formula that you can use. So let's take a look at this example. Write the equation of a line with slope of 3 and through the point -1, 5. So let's start by identifying our x1, y1 values. So -1 will be your x value and 5 is your y value. Next, we identify our slope as 3. So you substitute those values, so you get y minus 5 equals 3, parentheses, x minus negative. And then we go through and simplify. The minus negative becomes a plus, as you can see here. So this minus negative will become a positive, or a plus. And then we can distribute the 3. So we get 3x plus 3. And then we can add 5 to both sides. Getting us y equals 3x plus 8. Alright, our next option is option 3. So if you're given 2 points. Well, if you're given 2 points, then that means you're going to have to use the slope formula to find slope. So just a refresh, here we go. You can then choose one of the given points, substitute the values into the point slope form, like we just previously did, and solve for y. So let's take a look at this example. So step A would be to solve for the slope using your slope formula. So we get, in this case, a -1 value. Then choose one of the given points and substitute next. So we substitute the first coordinate, x1, y1. So -2 goes in place of x. And remember, if you have a double sign, that becomes a plus. And then the 5 substitutes for y. And it's the y1 and the x1 that get replaced. This y and this x that don't have a little sub number value stay as is in the equation. And then we can Distribute that -1, add 5 to both sides, and this then would be our slope-intercept form, and this is our point-slope form. And it is completely fine to leave equations in this form or change things around, manipulate the equation to get it to this form. So you can manipulate between the different forms of equations. Alright, so let's take this refreshed knowledge from Algebra 1 and write some equations of parallel and perpendicular lines. So just to refresh, parallel lines implies equal slope values. And then perpendicular lines implies opposite reciprocal values. In other words, if I multiply the two slopes, it should always equal -1. Alright, example 1. Write an equation of the line passing through the point -1, 1 that is parallel to the line y1 equals 2x minus 3. Alright, so if we're getting a line parallel to this given line, we've got to consider its slope. And we know that parallel lines have equal slopes. So, I then first identify my slopes and the point that it's passing through. So my first slope of the given line, so for line 1, slope 1 is equal to 2. So that means my second equation's line must have also a slope of 2. And I need it to pass through the point -1, 1. So I substitute into my point-slope form, simplify, distribute, move some things around, and get y equals 2x plus 3. This is the second equation that is parallel to the first one. Alright, let's grab your calculators and make sure we know how to graph these, because this is a great way to know and check whether you are getting the right equations. So, click on the menu key. Click on the home key first. Then you should see this screen. We want to graph, so select B. That'll get you to a screen that you should see a grid. And so to get to this feature, hit the menu key, and that'll open up this first menu. Go down to option 3, and that's going to open this second menu, and we want to graph a function. So select number 1, function. Next, that will take you to an open screen here where you can type in whatever function. So this will be blank when you select that function feature. And so you just type in all of the equation that you want to graph. So you'd hit 2, and then down here you see x plus, so your plus key, and then the 3. Hit enter, and then you should get a graph. And then do all those same keystrokes again to get a second graph. So you go back to menu, and then select function, type in your function, hit enter, and you should see a second line. And you can see that they are parallel. Alright, so let's take a look at this example, writing an equation of a perpendicular line. So we want to write an equation of the line passing through the point 2, 3 that is perpendicular to the given line. Alright, so here's our given line. It's in standard form. So let's consider in standard form, in order to identify the slope, we would need to move some things around. So we'll subtract that 2x from both sides, get it into slope-intercept form. That will allow us to identify the slope. And now we can identify the perpendicular slope, which has to be the opposite reciprocal. So it would be positive, and then reciprocal would be flip the fraction, so we get 1/2. And we need our line to pass through the given point 2, 3. So now we have a slope, perpendicular slope, and a coordinate that we can pass through. So we'll plug in, substitute values into the point slope form. And if I want to get rid of a fraction and get it into standard form, I need to multiply everything, both sides, by whatever value I'm trying to get rid of in the denominator. So in this case, I'm trying to get rid of this 2 in the denominator. So I multiply both sides by 2. So I multiply this side by 2 and the other side by 2. you get 2y minus 6 equals negative x plus 2. And then when you add x to both sides, you get x plus 2y, and add 6 to both sides equals 8. So now you have it in standard form. So this equation is perpendicular to the first equation. All right, and you can check these answers to see if they are correct by graphing. So go through the same keystrokes again, get to the home menu, select graph, and this time when you go to option, you want to go to option 3, graph, which will open up this menu, and instead of that first option, function, go to equation templates, then select line. Next, after you select line standard. So the new updated operating system allows you to graph in any format. So this is the coolest thing ever. It's going to open up a screen where you can type in your A value, that's the coefficient of x, your B value, which is the coefficient of y, and your constant value, which is after the equal sign. So you can check that equation that we just figured out, type it in, and see the results. And you should see perpendicular lines. All right, so now we want to incorporate finding the distance from a point to a line. So from the point 1, 0 to the line, negative x plus 3. So we're kind of incorporating two different lessons. When we talked about the distance from a point to a line, we learned that it was the shortest distance, and that's always going to be the perpendicular distance from a point to a line. So we want to look at perpendicular slopes. So you can graph your equation just to see, and the point, so you can see kind of like a visual of what you're trying to do. All right, so we've got this line that we're going to start with. And we need to identify its perpendicular slope. So it's going to, if it's a -1 slope, then it's got a +1 perpendicular slope, passing through the point 1, 0. So we plug into the slope-intercept form, simplify, and the second equation then is positive x minus 1. So we graph that, and we see that they intersect at 2, 1. So when you're solving a system of equations, you can solve by graphing, and you're looking for the point of intersection. Now that we have the point of intersection, we have 2 points. The point given that was not on the line, and we want to find the distance from this given point to this given line. So now that we have a point of intersection between a line that can pass through the given line and is perpendicular, we've got 2 points that allows us to figure out distance. So plug into your distance formula and solve order of operations. So we get 1 squared plus 1 squared, which is 1 plus 1, all into the radical, simplifying to 2. So the exact distance is square root of 2 units. If we type this in the calculator, we can get an approximate distance. So the approximate distance, always round to 3 decimal places unless told otherwise, is going to be 1.414 units. So the distance from the point 1, 0 to the line y equals negative x plus 3 is about 1.414 units. All right, so take a moment to pause the video here and try the next 2 examples all by yourself. And then unpause the video to check your answers and work. All right, so there's your first equation. Sorry, the equation to the first example, which is going to be negative 2x plus 3. And the equation to the second example should have been negative 1/4 x plus 11. And that's all for this lesson. See you in class.